Alright guys, I have set up this hydraulic bench for this experiment. Floor the notches. Here we can see the rectangular notch and the point gauge to measure the head over that weir, and we are using this tailing baffle to make the flow laminar type and remove the turbulence. Alright, so initially I have set this point gauge to 0, as you can see. Its value as 0, and it's currently touching the bed level of this channel, right? So after turning it on and setting a particular flow rate, a particular head will flow through this weir or notch, and we can easily find that height or head over this particular notch by simple calculation. That is subtraction of total head minus this crest level of the notch. So let me do that. Let me turn on the pump. Okay, so I can set discharge from this knob. Let me make it 30 liters per minute. Okay, so now you can see the flow nap, and the water level is rising over this notch, right? So here on the upstream side, at distance of it at least 4 times, this distance should be at least 4 times this head, right? So I'm taking the value of head by adjusting this point gauge. Just give me 1 second. Alright, so after a minute or 2 minutes the flow is stable and it's quiet. So as you can see, I have moved this point gauge to just touch that surface of water, right? You can see that small circle it's making on the surface of water. So here now you can read the value in millimeters. So this is 110 millimeters, right? So I can note this value, 110 millimeters. Also remember that you can measure the flow rate from this gauge, which is volume divided by time, volume collected in a particular time, right? So you can also find the discharge from that relationship, but these two should be nearly the same, right? So I'm taking that value of 30 liters per minute. So let me show you the calculations afterward. Alright, so for rectangular notch I have this formula: Q is equal to CD times 2 by 3 times under the square root 2G times B times H power 3 by 2. So here from the geometry we know that our notch has B value of this value of 30 millimeters, right? So I have converted it to meters, and then I have measured the total height above the base of this weir, which was 110 millimeters, right? And also I know from the geometry that this crest level height from the base is 70 millimeters, right? So I can find the total head over this weir, which is equal to 110 minus this crest level value. So we have H is equal to 110 minus 70, 40 millimeters, and then I have converted it into meters. Also I know that flow rate is 30 liters per minute. I have converted it into meter cube per second. So now let's put these values in this formula: 3 times that flow rate, 2 into G value, and then we have the B value, and then we have the H value, right? So after working out, we found out the value of coefficient discharge for rectangular weir, which is 0.71. I hope you have liked this video. Please give it a thumbs up and subscribe to my channel.